Hello! How are you today?
So the goal of this video is to talk about qualitative perspectives on acidity. And to determine that, you need to look at conjugate base stability, which is determined by 4 different factors. The atom that the negative charge is resting on, the resonance in the molecule, if any, the induction if there's electronegative atoms pulling charge away from the base, and then the orbitals that the negative charge is resting in. And those can be sp3, sp2, or sp.
To determine the acidity of a compound, you have to look at the conjugate base. You deprotonate the compound, and what atom the negative charge is on affects the stability. So, if the charge is on a more electronegative atom, it's better stabilized, and electronegativity increases from left to right on the periodic table of elements. So a charge on like sulfur would be more stabilized than phosphorus. The other thing that determines which one is more stable on the atom is size. As you go down the column on the periodic table, the atoms get bigger, and they are more capable of stabilizing the electrons. The white strips on the balloons represent electrons.
Okay, resonance is the ability to distribute a negative charge over 2 or more atoms in a compound. Resonance increases the stability of the compound, which in turn increases the acidity of the compound.
A localized lone pair has to support the charge on just one atom of the compound, which makes it more unstable. It is analogous to someone stepping on a nail. All of the pressure is centered on a small surface area, which causes more damage on the human body or more strain on a compound than if the pressure were more widely dispersed. A delocalized lone pair is able to distribute the charge through resonance over 2 or more atoms in the compound, which makes it more stable. This is analogous to those who lay on a bed of nails. Although stepping on a nail would hurt the body more because it is centered on a small surface area, those who lay on a bed of nails are able to take the strain more because the pressure is more widely dispersed over a greater surface area on the body.
Okay. So induction works by drawing the negative charge away from the spot of deprotonation to stabilize the conjugate base. So for instance, if you had a carboxylic acid that was deprotonated and you wanted to stabilize it, you could attach 1, 2, or 3 chlorines away from the negative charge, which wouldn't be resonance but would stabilize it by distributing the negative charge across the molecule. Basically what the chlorines do, because they're electronegative, is they would draw that negative charge away from the isolated spot. And you see this as evidenced by the lowering of the pKa's with each subsequent chlorine. So if you had 1 chlorine, it will lower it a little bit, and if you had 2, it will lower it a little bit more, and so on and so forth. So in an attempt to create an analogy for induction, we have a balloon that is being weighed down by a pin, and if you can imagine the balloon as one atom bearing a negative charge, it would seem logical that multiple helium balloons would be able to lift the pin. If you can imagine the height of the pin as synonymous with how stable the conjugate base is. So if you imagine the pin as the negative charge and the height of the pin as the stability of the conjugate base, you see that with 3 atoms holding the negative charge, the stability goes up. The last factor that affects the stability of the conjugate base is what orbital the negative charge rests in. So if you have an sp3 orbital, the negative charge is held far away from the nucleus, which is positively charged, and would therefore stabilize that negative charge. When you have an sp2 orbital, it gets a little bit closer, and then sp is even closer. And you see this in the difference of the pKa's. For example, a regular alkane would have a pKa of 50, and an sp2 alkene would have a pKa of 44, and an sp triple bond alkyne with a negative charge on it would have a pKa of 25.
This one is for those who don't know chemistry. pKa values and acidity. When you come up on the table, the acidity's up. And when you go further down, you be basing it up.
For real? What affects the acidity?
It's called REO, and it's just this C, which charge the atom is on is A, based on size and electronegativity. Royce resonance.
Ooh, what is this?
Look how the charge spreads over the after changing location of the pi bond, which changes the location of electrons.
R is induction, which pulls the charge over by might, and it pulls the charge
Toward the added atoms with negative charge. O is orbitals containing different kinds of bonds like sp, sp2, sp3. When differs in how close the electrons is, that is REO, how pKa goes up.
that clears it up.
Now check the deuce up.
Fluorine confused with chemistry. REO and acidity.
Now she knows that can she know that chemistry? Can she know that chemistry?
And this was our resonance structure. See how the charge moves over the other?
Through changing location of the pi bonds, which changes the location of the electrons.
Yay!